Hey guys, it's Dr. Pauly. Today we're going to go over the SolidWorks practice exam. Some of you had issues with this during our midterm, and I'm going to go over it step by step. Now, up to this point, we've pretty much been making parts individually. They give you a set of dimensions, we create the part, we're done. The way the SolidWorks practice exam works is it wants you to design with intent. And that is, we're going to create this part, but we're going to create it with the intent that we're going to change it later on. And that's just, smart modeling. If you know that you're going to have a part, let's say that there's two shafts that go through this, and eventually, we're going to have to change the size of the hole to allow different size shafts and stuff like that. And so what I'm going to go over, start off, is I'm going to explain this in general, and then we're going to create what's called linked dimensions, and then we're going to use those dimensions in what's called a design table to make different instances of this part. So first off, let's look at this part. Here's the front view, here's the right side. These three views here, here, and here are section views, and you can see the cutting plane lines that dictate what's shown. Let's look at HH. Here's HH through HH, and you'll notice that there's a cutting plane line, HH through HH, and notice the arrows are pointing down. What that means is anything behind it has been cut off. And so we're looking from the top down on this part, removing this top. And you can see right here that everywhere that there was solid material that's been cut by the cutting plane has section lines, and that's what those lines mean. So they've cut the top off primarily to show you the D dimension here and here, and they've put in this fillet here because it was too crowded in other places. The JJ through JJ cutting plane line goes lower, and it removes the entire top half, so because what they want to show you in JJ through JJ is this rib looking feature here. And so they just went ahead and they came up a little bit and cut it off and removed all this. And so that's what you can see there. The next one is KK through KK, and if you look right here's the cutting plane line. And since this is the top view and the arrows are pointing this way, it's removing this part of the object, and we're now going to look at it based on the front view with that stuff cut. And here you can see the cutting, the section lines here, and it's exposed half of this hole here, which is F. And the reason they cut it is to show you the depth of this extruded cut here, or this channel, if you would. Okay, and notice it's only got 5 millimeters left. Alright, and here of course is our obligatory isometric, so you can kind of see the image as a whole. Now if you look at these dimensions, it's got A, B, C, here's D, E is right here, and then they've got X and Y, okay, for these outside diameters. Alright, if we scroll down a little bit, it tells us how to set the, what to set the material to, how many decimal places. Origin point arbitrary means it really doesn't matter where you put the origin on your part. All holes are through unless otherwise shown. And then here for those dimensions A, B, C, D, E, F, X, and Y, they've given you a set of dimensions. Now they will tell you that here, the dimensions that are linked or updated and are variable will be labeled with letters. In other words, these are going to change later on. Okay, and if we go on and look after we build the first part, you'll notice that they just give you a new set of specs for part 2, and they've went through and they've changed some of this. Okay, then if you look at part 3, well, it does the same thing. They've just changed some of these dimensions. Now if you did this old school, like you've been working on up to this point, you would build 3 different parts. Well, it would be the same part, but they would have different sets of dimensions. That takes a lot of time. What I'm going to show you is how to link your dimensions and use a design table to create different instances of this part. And it's really a powerful feature. So as I go through, make sure you're looking at this, okay, because I'm going to have this off screen. Make sure you're looking at this and see what I'm going over and model it with me. Now obviously how to get started on this, I'm going to start with the base and I'm going to build up from there. So I'm going to build the base, then I'm going to add this piece here, then I'm going to cut, well, I can't cut this out yet until I build the rib, because if you look, it's 999, yeah, 999 millimeters. Okay, so I'm going to use an offset to build that. So I'm going to have to build this first before I can go ahead and do that channel. Alright, so that's how we're going to start. So follow along, listen to me as I go around along with it, and do what I do. So the first step is I'm going to make sure I'm on metric, and I am. I'm going to go over to feature, I'm going to say I'm on extrude, and I'm going to use the top plane. I'm going to use a corner-to-corner rectangle, and I'm just going to draw it there. Finish that, hit escape. I'm going to grab the midpoint and the origin and align them vertical, and I'm going to take this midpoint and origin and line them horizontal, and so that way when I put dimensions on here it'll be constrained. Now the first thing I'm going to do is use A and B dimension, and I know they're going to change. Okay, so I'm going to create link dimensions with those, and I'm going to label them appropriately. Alright, so I'm going to show you how to start that. First thing I want to do is go over here to my hide show items, and I want to make sure that view dimension names is selected. Okay, and then I'm going to go ahead and dimension this one. Now this is going to be a dimension, so I'm going to go up here where the name of it is, which is D1 on at sketch 1, and I'm just going to put in A. Okay, so now it's A at sketch 1. Alright, the value for A is 213 millimeters, 213. Alright, and I'm going to use this right here. Some of you use this, some of you don't. You can click and say regenerate the model with the current value. So what that means is if I change this value to say like 200 and I hit regenerate, it automatically updates it and while I'm still in my dimension. So I'm going to change this back to 213. I'm going to update it. It's good. I've labeled it A, and so we're good so far. Okay, and I'm going to say OK. I'm going to do the same thing with B, the B dimension. So I'm going to click here, come down here, and I'm going to name this one B. And I'm going to set its dimension value to 200, and I'll say OK because I'm done with that. And notice it's fully defined. So we're good so far. I'm going to hit escape, and then I'm going to hover over A, and I'm going to right click on it, and you're going to see right here that there's an option to link value. So I'm going to say okay, I'm going to link the value, and I'm going to give it a name, and I'm going to call it A because you know it's dimension A, so I'm going to call the value A, and I'm going to say okay, and you'll notice this little chain link right beside it. Okay, that means it's now a linked dimension. Same thing for B, right click on it, link values, I'm going to give it a B and say OK. And I'm finished with this. I've got a 213 by 200, which is dimension A and B, and I'm going to finish, and I'm going to extrude that up 25, like that. Now I'm going to work on this raised area. Now, sometimes we neglect to name things, and sometimes it comes in real handy when you have to go back and edit. So what I'm going to do here, instead of calling it Boss Extrude 1, I'm just going to call it Base. Okay, and I can just call it Base Extrude if I want, so I know the operation. But all the operations have icons, so it's whatever you want to do. But I just went with Base Extrude. Now let's create that little raised area right here. So I'm going to do another Extrude Base. I'm going to click on the top surface here. I'm going to use my corner to corner. Snap to this corner, come up this way. I'm going to dimension it 60 by 60. And I don't have to do any link dimensions on these. Notice every time you start a new sketch, the first dimension is always going to be D1, the second dimension will be D2, etc. Okay, and you see that more now because I have it where you can see the names. I don't need to do any links on these because they are just simple dimensions. They're not going to change. They're not variable. I'm going to put that 15 millimeter radius fillet in it, in this top corner. Hit enter and say OK. Now, the way the drawing says, it says that it's 35 from the bottom to the top of this, and at this raised area. Well, I've already got 25. So basic math says 35 minus 25 is 10 millimeters difference. Okay, so I'm adding 10 millimeters to that 25. And there is that 35 height right there. Okay. Alright. So that's that so far. We're going to go ahead and move on, and we're going to put the rib on. Okay. Now the rib is another extrusion on this surface, and it starts off by, let's go ahead and give ourselves two lines, one vertical and one horizontal. Okay, and the lengths of these lines are 80 each. Okay, now the position from this line to this edge is C, and the same thing for this line to this edge is also C. Alright, so let's go ahead and knock that out. So let's do a smart dimension from here to here. Alright, and the current value of C is 170, so 170. Okay, I'm going to change this name to C. I'm going to update it, and I'm going to say OK. Now, I'm lazy. I'm not going to do the same thing here. Okay, and obviously you can't have two dimensions with the same name in the same sketch. So what I'm going to do is I'm going to hit escape. I'm going to right click on this and say link values, and I'm going to give this one the value C, name C. Okay, now it's a link dimension. So now let's go ahead and smart dimension from here to here, and I'm not going to name this. I don't have to. But I am going to make it equal to, so I'm going to say equal, and it pops up the menu, global variables, functions, and file properties. Well, I've created three global variables by creating link dimensions. So if I hover down over global variables, you'll see that there's A, B, and C. Well, I'm going to make this one equal to C, and I'm going to say OK. And there it goes, 170, and you can see the formula symbol right there. And there we go. So it's 100, 170, 170. Now we have an arc that goes right in here, and the origin of that arc is if you extended this line and this line out where they intersect, okay, would be the center point for that arc. So I'm going to use a center point arc, and I'm going to start at one of these points, and I'm going to come out until I find that intersection right there. And once that's there, I'm going to click, then I'm going to come out, and I can either come down to this one or go over to this one, doesn't matter, but I'm going to stop at an end point. Now I'm going to click there. Then, now sometimes you have to go around at least once to get it to draw the way you want it. So what I'm going to do is I'm going to come down with this arc until I hit that point. I'm going to click. Okay, and we're good so far. So that's that arc. Now, here's an issue that you'll run into if you're not careful. They did not give you the dimension of this arc deliberately. Okay, because if we change the value of C, it's going to change the distance between this center point here and this point here. Okay, it's going to either, if we bring them down, it's going to bring it in this way. If we increase it, it's going to go out this way. Okay, and so what we need to do is, if we want this defined, is we're just going to take, I'm going to hit escape. I'm going to grab this center point, I'm going to hold control and grab one, either that point or that point, it doesn't matter. I'm going to use this point. And I'm going to say, make those 2 points horizontal. And now it's fully defined. And what that means is if this ever changes, it's going to bring this point down with it. And let's give that a whirl, okay? So let's change the value of C to, let's say, 150, and hit enter. And you notice that everything's scaled in, okay? Let's go back and do 170 like it's supposed to be, and it goes back out. Okay. Now, if I did not have that, let me delete this constraint here, and if I had gone in and put a numeric dimension, escape that. Okay, and let's say I put a numeric dimension in there like that. Okay, so there's no geometric relationship, it's just the standard dimension. And I go in and I change this to 150. Okay, notice that the arc center point still stays there, and that's not what I want, because the way it was designed is that center point should always be where these two lines would intersect. So let me change this back to 170. Notice I'm changing the value of C, and this one says it's equal to C. Okay, I'm going to hit escape. I'm going to delete this dimension, and I'm going to go back and put my constraint on there. And pick those horizontal. Alright, so there's a little quick lesson right there. Alright, so we've got this outside part done, and now we're going to offset it in 15 millimeters. Alright, so we're going to say offset. I'm going to go ahead and put in my dimension for 15. I'm going to make sure I have select chain. Now I'm going to show you a handy little trick here. You'll notice that here it says capped ends, and it's grayed out. It's not, you can't select it yet. Okay, I'm going to select one of these parts here. It doesn't matter because it's going to select the whole chain. And notice that now it becomes available for an option. I'm going to go ahead and say, listen, I want to go ahead and cap the ends with a line. Okay, so I'm capping the ends with a line. And what that'll do is this. This is my original line. If I click on this side, it's going to put it where that yellow line is. If I click on the inside, it's going to put it on the inside, which is where I want it. So I'm going to click on the inside. And if you notice, it went ahead and capped the ends for me. I didn't have to go back with a line tool and add those. Alright, so we're good. It's just a handy little thing that makes our lives a little bit easier. Okay, and so there's that part, that shape, and now we're going to extrude it. So I'm going to say finish. Okay, I'm going to tilt this over a little bit so you can see. And the height of this from the bottom to the top of it will be 95. Well, I started at the 25 mark. See, I've already got 25. So I only need to extrude it the difference. Now, if you don't trust your math, you can say 95 minus 25, which is 70. Or you could just type in 70, just whatever you want to do. Now, and again, this is simply a numerical value because it's not designed to change any in this part, according to them. So I'm going to say, okay, there it is. All right. Now, we've got the raised area here. We've got this rib, for lack of a better term, and now we're going to create this channel. All right. Now that channel, it says that it's 9 in. Okay, and then we put in some fillets. So we're going to use another. Well, we're going to use an extrude cut this time because we're going to cut the channel in this surface. I'm going to use offset, and I'm going to change it to 9. Okay. Select change should be available. I'm going to click in the inside of this. You notice everything here highlighted orange. Okay. If I do that, it's going to grab everything. Okay. Now, again, there's my little arrow. If I click on the outside, it's going to expand it out, but I want it to go in. So I'm going to click on the inside of this object, and there's that shape. All right. It says it has 6 10 radius fillets. So let's go fillet. Change the radius to 10. And knock out those 6 corners, 1, 2, 3, 4, 5, and 6. And say OK. And there we go. Alright. So we've got that finished, and now we're going to cut it in. And we already talked about how far in that cuts, and it's going to cut in 20. So I'm going to finish the sketch. My depth, I'll roll it around so you guys can see, is going to be 20. And there we go. Okay. So, I've got my raised area, I've got my channel, I've got my rib. The next thing I want to work on is either I can put this hole in here, which is not a problem, or I can go ahead and put the other stuff. Well, since I'm up here, let's go ahead and put this hole in. So I'm going to use the hole wizard. Type is going to be a counter bore. ANSI metric. I believe they say it's a hex bolt ANSI B18235. B18235. Alright. Size is M8. Fit is close. Alright. and now it has some custom dimensions on it. So I have show custom sizing selected. See that? So there's show custom sizing. And I'm going to change these. Now whenever you change something from the default, it'll highlight it yellow. So it just lets you know that it's been changed. So it's 15 millimeters for the counter bore. It's 30 millimeters, 15 millimeters for the hole, through hole. 30 millimeter diameter for the counter bore, and the counter bore goes in 10 millimeters. In condition is through all. And we're good. Make sure none of this stuff here is selected. Alright. Now I'm going to go over to positions. I'm going to say this face is where I'm going to put that hole. Now I can't just I could click it and then dimension it. I like to go ahead and put my construction lines in first. So I'm going to say construction line, do not snap to, well, I can snap to this midpoint, yeah. Actually, since I didn't put those fillets on yet, it should allow me to do that right there. And it does. Okay, that's midpoint to midpoint. Okay, so technically I should be able to get a point, line up, find those two, and there I am. I'm good. Okay, now if you don't trust it, you can always go ahead and put in some construction lines and make sure that those are going to be 30 each way from those midpoints. And so if I dimension that, and you'll notice it's 30, and it's going to say it's over constrained, so I'm going to hit cancel. But I just wanted to show you that you could put in your construction lines first and go ahead and dimension them if you want to, or if you're fairly comfortable, trust the snap constraints. Okay, so I don't need those, so I'll hit delete on those two, and there it is. It's all happy. So we're going to finish that, and it goes ahead and applies that counter bore hold for me. So let's go back to the top view, and now we're ready to put those cylinders on. Now, one thing you'll notice about those cylinders, and I'll go ahead and bring this back over just real briefly, is that while D is one dimension, it's set in, or set outside of it, by 10 millimeters here and here. Okay, so you actually have to start the dimension 10 out and then come in. Now, there's several ways to do this. You can do an A, B, or side 1, side 2, whatever, extrusion, two-sided extrusion. But since we're going to use one dimension, okay, and I want to make my life easy, what I'm going to do is I'm going to just go ahead and create a offset plane on both surfaces here. That's 10 out, and then we're going to draw our circles on those planes. That way we just have to extrude one way, one dimension. Alright, so here we go. Let's see, let's get the front view here, and I'm going to say I'm going to do an extrusion. Oops, can't do an extrusion yet. Sorry, I have to put my reference geometry on first. So let's go ahead and do that. Reference geometry plane, and first reference is I'm going to pick this side here, which is my reference plane, and I'm going to use an offset distance of 10, which, hey, look at that, it's default. So I'm going to say OK, and what you'll notice is that plane is 10 millimeters out from this surface here. Okay, now here's a little trick. Make sure you click off so that plane is not selected before you put on your next one, or you'll have to modify some stuff because it'll automatically assume that that plane is a reference. So make sure that plane is not selected. Do another plane. First reference is going to be this side. Offset's 10. I'm good. Okay, and I'll look at those, make sure the offsets were the right way, and they are. Okay, so now plane 1, have it selected here. I'm going to do an extrusion with a circle, and I'm going to snap to the midpoint of this, which is where the cylinder starts if you look at your drawing, and I'm going to come out this way. And this is dimension X, so I'm going to say smart dimension this. First thing I'm going to do is change the value to X, and the value for X is actually a formula, and it's A divided by 3. Okay, so down here I'm going to highlight all this. I'm going to hit equals because I'm going to do a formula, and I'm going to use a global variable A, and I'm going to divide that by 3, and I'm going to update it so you can see that it works. And I'm going to say OK. So there's that one. Now we're going to finish it, the sketch. And it's going to come out here. I'm going to make sure that my direction goes this way. I'm going to use a blind. And the distance of that blind is going to be D. And D is set to 130 millimeters. So 130 millimeters. Alright. Again, look, since I'm coming from that plane, I've already got my 10 offset this way. And I'll say OK. Now, I don't want to have to change a lot of things on this. So I need D to be a link dimension as well. Okay. So how do I do that? Let's see, this X change, I don't think X changes any. A divided by 3. A divided by 3. It probably will later, so I'm going to go ahead and make that one a link dimension as well. I don't think I did. So let me go into my boss extrusion, edit my sketch. Right click on my dimension, link its value. Oh, it's okay, never mind, it's driven by an equation. Yes, okay, I get it. Alright, we're good. I don't have to do it that way. Alright, so now we're going to make D a linked dimension. And how you do that is I simply select that extrusion, and you'll notice that there's that dimension right there. Okay, I didn't have a chance to name it or anything while I was doing it, but I can go back to it, and I'm going to double click it real quick, and I'm going to call this one simply D, and it's 130, so we're okay. We're good there. Now I'm going to right click on the dimension and say link its value, and it's going to be called D, and I'm going to say OK. So now it's a link dimension. Okay, so again, you just click the feature, and the dimension will be exposed, and you can do whatever you need to that dimension. Alright? Alright, so let's do our other one here. So I'm going to highlight plane 2. I'm going to say I'm going to do another extrusion. I'm going to use a circle. Start at the midpoint, come out there, and this one's Y. Okay, and Y has a different formula, so come out here. First thing I'm going to do is name it Y, and its formula is B divided by 3 plus 10 millimeters. So we'll say equals B divided by 3 plus 10 millimeters. Okay, and I can, if I wanted to, I could come down here and put millimeters, whatever. But by default, it's set for millimeters, so we're good. And I'm going to say update it, and there's the formula. And I'm going to say, now if you want to see what the variable is, the value is, you can always go back and forth with it like that by clicking that equation symbol. Okay, so B divided by 3 plus 10 is that one. Okay, and then I'm going to finish that sketch. I need to flip that blind, and here I'm going to say equals, and I'm going to say global variable D. Okay, finish it, we're good. Okay, now I'm done with those planes, so I'm just going to go ahead and hide them. Just get them out of my way. And now let's put that hole through here, that E. Okay, so this is going to be an extruded cut. This surface, I'm going to take a circle, hover, highlight, draw my thing, dimension it. I'm going to call this one E. And E has just a straight numeric value right now, and it is, E is 41, so 41, enter. Okay, so E is 41. Now, hit escape, right click on it, link, make it E, say OK, and we're good there, so finish. Now, we know that we're going to change the size of D. And so if I do a blind cut, I'm going to run into problems, okay? Because if D gets longer, the hole won't go all the way through it. So now is where you start using another geometric constraint, like up to surface. And I'm going to say I want that to go to this surface, And there it is. So if that surface ever moves, gets longer or shorter, it'll adjust the extruded cut. And I'm going to say, okay. So there's that one. So now I'm going to come around here and we'll do the same thing on this one because it's also E. So we're going to do an extrude cut, this surface, circle. Let's dimension it. And now that we've already got E, I don't need to rename this one because, again, I can only have, there's no point. And so I'm going to say that this one is equal to the global variable E. Say OK. So there it is. Finish that. I'll move it around this way. I'm not going to do a blind. I'm going to do up to surface, this surface. Good. Say OK. And there's that. Now the only two things I don't have done here so far, I haven't put my fillets on. So my fillets are, the outside fillets are 10, I believe. Yes. So there's my, that one, this one, and that one. Should be 4 of them. Yep. There's that. And now my chamfer. Chamfer, it's 2 millimeters by 45 degrees. It's on this edge, that edge, that edge, and that edge. Okay. So we should be good there. Say OK, and there is that. Now the next thing I need to do is to change my material to alloy steel. So right click on material, edit material, steel, alloy steel, say apply, and close. Close it out. Now, if everything is correct, alright, if everything is correct on this, then my mass should be 14,207.34 or 340 thousandths. Okay, so let's check it. So let's go to evaluate mass properties 14,207.34. So right on it. Okay, so this part is correct. All right. Now it's very important that we did this planning for the future, and in the next video I'm going to show you why that was important. Alright, and how we're going to be able to knock out the other parts of this test within a matter of minutes instead of having to rebuild this part 3 more times. Alright, so we'll save that one for the next video.